Example of finding GCF. This is the first thing that you want to consider. First step. So in order to find the GCF for 18 and 35, for example, you want to make use of the tree diagram, and you want to find the prime factorization of 18, which would be, 18 is an even number, so we start with 2. This is divisible by 2. If I divide 2 into 18, you will get 9. 9 is not a prime factor. It's not a prime number. So we need to break this down a little further. I'm going to make use of 3. 3 times 3 will give us what, 9? We have 3 as a prime number, so this is where we will stop. We convert that into exponential form, and that would be 2 to the first power because you only have one factors of what, 2? And then we have 2 factors of 3, so we're going to write that as 3 to the what, second power. So basically what we have here is 2 to the first times 3 to the second power, which will give us 18. All right, so the factors of 18 will be 2 to the first times 3 to the second power. We also want to look at 35. And when you look at 35, you look at the last digit. In this case, the last digit is 5, which indicates that it's a multiple of 5. So we're going to make use of that. Divide 5 into 35, that would give us 7. We also know here that 7 is a prime number, so we know that we should stop. So what we will have here is simply 5 to the first power times 7 to the first power. Now, if you look at that situation, this is 2 to the first times 3 to the second. This is 5 to the first times 7 to the first. And as I mentioned to you, that word, common, is very important, because what you're looking at is what is the factors that are common in these two groups. Since there is nothing common, which is the same, in both of these groups, our GCF is equal to 1. And this is the only time that it will be equal to 1. Okay. Next, we want to look at something that we can take note of. I'm taking 12x to the third. I'm taking 45x to the 8th, and also a negative 9x squared. Those 3 terms. In order for us to find the GCF, first of all, I want you to look at the coefficients, which in this case is 12, 45, and a negative 9. Those are numerical coefficients. We're going to separate those things into factors, prime factors. 12 will be factored into 2 times 6, and 6 is 2 times 3. 3 is a prime number, so this again we will stop, and we would put this in exponential form. So that will become what, 2 to the second? Why? Because you have what, 2 factors of 2 times 3 to the first power, because you only have one factor of 3. Again, for your variable, it's already in exponential form, so we're going to leave it as such. So in this case, we have what, 2 to the second times 3 to the first times x to the what, third power. Second, 45. Again, 45 is a multiple of 5 because the last digit is 5. So we're going to have what, 5 times what, 9 is 45. But 9 is not prime, so you need to continue. We're going to break 9 into 3 times what, 3? 3 is prime, so you know we should stop. How many 3s do you have? We have what, 2 of them? And we only have 1 5. Try to keep those things in order. And we also have the variable, which is x to the 8th power. Again, it's already in exponential form, so you don't have to break anything down on that particular part. For your negative 9. Negative 9, first of all, I know it's negative, so you're going to have to take out a negative 1. If you remember your signs, a negative times positive will give us what? Negative. So the 9 is positive. I'm going to break that down as we did previously. And that would be what? 3 times what? 3. We want to break this into the form of exponential. So we have a -1 raised to the what? First power, because we only have one of those things. How many 3's do we have? We have what? 2 of them. So that would be what? 3 to the what? Second power. And of course you have your variable, don't forget, of what? X squared. So looking at those 3 boxes, looking at the 3 boxes, we want to find what is common. And again, I can't emphasize that enough. What's common in those 3 boxes? Well, first of all, let's look at 2. 2 is here, but if 2 is not here, that's a what? Base, and 2 is not there. So that means that 2 is not common. We proceed to the next thing, which is what? 3. 3 is here, 3 is here, and also 3 is there. The key thing here that you want to look at now is what is the smallest exponent for that base 3. And the smallest exponent, if you compare them, there's a 1, there's a 2, and there's a 2. What is the smallest? The smallest will be 1. So 3 to the first power will be your first part of that JCF. Then you need to look at your variables. Is that common? You have x to the third, we have x to the 8th, and we have x to the what? Second power. X is common, as you note. And what is the smallest? We compare 3, 8, and what? 2. 2 will be your smallest. So that means that you're going to have what? X to the second power. When you multiply that, you should get 3x to the second power. And we will classify that as your GCF. That is your greatest common factor. That is the highest number that can be divided into each of those terms. Okay? So this is the procedure in which you would follow if you're trying to find the GCF. First, that's your first step.